Hello people of the internet. Today we are going to work on a fun one. I actually wanted to do this yesterday evening, but then I decided to go out and didn't have a time for it. So first thing today we are going to work on this. Our goal as a Copper team was to migrate several projects that currently store data in our backend storage and migrate them to store results in Pulp. We have a migration script for it and everything. And when I tested the script on a smaller, simple projects, it worked fine. But then we decided to migrate our Copper/Copper pull requests project, which is a big one. We built every pull request from the Copper repository there, and it tracebacked. And we tried to debug it with Dennis from the Pulp team, and I think we figured out what's wrong, is what I wanted to say. The problem was, actually, let me show you. This is the traceback that happened in production. Actually, this is in my local Docker container reproducing the issue, but we got this error. And it's asset false, which is, let's say, not ideal because assets in Python production code are not a good idea. But the problem is, basically, here is the response from Pulp, and somewhere here is the description. Cannot create repository version more than one RPM package content with the duplicate values for name, epoch, version, release, arc, and location ref. Which means, basically, we are trying to upload two packages with the same NEVRA but different content. Now, this is a use case that we definitely need to support in Pulp, in Copper. This is not something you would want in Koji, but we definitely need to support this in Copper because Copper is a messy pile of experimentation, and for example, a lot of some package maintainers in Copper never bump their versions. Some packagers like me, for example, when they are creating a new package, they set the version to 1.0 and release to 1, and just do 50 iterations of the package until it builds correctly and builds the exact way I want it. So I have many packages that are 1.0-1 versions, and they have different content. Once I figure out the package, then I properly bump the release and version numbers, but until it's working, working as expected, I just keep it as is. So, and there are many variations what people do. So we need to support this case, definitely. And what's interesting is we actually support this case while building, because if you have a Copper project that has results in Pulp and you build a package upload the results to Pulp, and then build the same package with the same NEVRA but the different content, and build it in the same project, then it doesn't trace back. It actually uploads the new one and throws away the old one from the repository. So that's something you would expect, and the same thing that happens in Copper. So just a quick just to quickly show you how you can have same NEVRA but different content, because if you are not a packager, maybe you don't realize. For example, we talked about this with Dennis, and I showed him the simple way how you can achieve it. So for example, I have not here. I have some package that I maintain. It's some themes for Rofi. Doesn't matter. And originally the package was like this. This line wasn't there. And for example, if I do just simple like this and don't bump any version and any NEVRA or version or release, then I have a different content with the same one. So that's a simple way to do it, right? Okay. Anyway, let's get back to this and let's try to fix it. I need to switch some music because it's distracting me. Okay, I think we are ready now. So this happens from the Copper change storage script, which is what I'm running here. Maybe I can run it again to make sure the traceback is completely reproducible. It would be a good idea. Yes, so the traceback is reproducible. So it comes from a Copper change storage script. And so let's jump to the script maybe. Copper change storage on the right side. Line 185, this is the one. And then from create repository version, so repository version, we have it on the left side, which adds content in the Pulp client, right? Add content, and then inside of it, add content, and then inside of the try log and so on. So I think we don't have to fix it this deep. We need to probably go here. Those package hrefs will be a list that will contain hrefs to Pulp, which are basically IDs of the packages, and there will be duplicities, I think, because I probably forgot to explain this in the beginning. When building one package and then another package with the same NEVRA but different content, it works. It only doesn't work when trying to migrate the project. And the reason is that it is not one package after another, but we are basically trying to say, put all of these packages inside of a repository, and at the same time, and there are duplicities. So Pulp has no idea what package of those is the older one and should be thrown away from the repository. So that's why it tracebacks. So what we need to do is figure out where we get the list of all of those IDs that we want to, or all of those hrefs that we want to put inside of the repository. And we need to manually filter it to not put any duplicates there. So yeah, that will be our goal, basically. And so if you see the migration script here, it calls create repository version, and it already has the package hrefs. So we probably need to filter it right here. It scans the directory and then figures out the result there, skips some directories. Okay, so here, package hrefs. I actually think here, if we put the code here, it's too late, because we only knew the hrefs now, and the hrefs, well, let's do it. Let's run it. All package hrefs is funnily enough an empty array. Why is that? Next. Oh, okay, so yes, so we only have the hrefs and we don't know anything about it. We could query the pulp and figure out the information, but we would have to send so many API requests, and yeah, we don't want to do that. By the way, I think we will not try, but I think if we would query this one and this one, we will get the same NEVRAs. And maybe we can even try it if we do. Do we have self-storage here? We don't. Do we have storage? We have pulp storage, client, get by href, and we do this. This will be foo, and we will query the other one. And this will be bar. So and I wanted to do JSON and JSON. So foo and bar. This looks different. If we do pp. So this is Ruffy themes. That's my reproducer actually. Okay, if we do bar version and foo version, if we do foo name and bar name, if we do bar release and foo release, and arch was the last one, foo bar. Okay, so this was source RPM. Okay, so this is a different one. But I think if we do a next one, oh no, okay. Interesting. I actually expected those to be the same. But regardless, I want to continue with my original plan, which was not trying to fix it right here. I want to go to upload build results, which is here, and modify this function. So I didn't write this function, and I didn't even properly review the function, but it's more complicated than we need it to be right now, because the original idea was having a thread pool and uploading in parallel, but currently we dropped the idea of the parallelism and actually do just one thread at a time, because of some issues with Python request score dumping. But so we could simplify the function, drop the parallelism, and so on. But we will try to keep the parallelism, keep the changes at minimum, and just fix the issue. And my idea was, if you take a look here, we traverse the result there, right? And then if we find RPMs, so we filter out RPM files, so here we only have RPM files. If we find RPM files, then we do some labeling, and then we save the path and prepare a future execution of the uploading. And then finally we go through all of these. Oh, we don't actually, we submit right here, never mind. But then we go through all of those promises or futures and collect them, collect their hrefs, and say that it was uploaded. So my idea was to not upload here, but only store the path and then filter out all the paths, all the duplicities from the paths. And if there are duplicities, then to compare when were the files created and use only the newer one. So ultimately we should end up with package hrefs list that has no duplicities. And by the way, let me take a look at the error again here. Name epoch arch and location. Okay. Never mind. But yeah, we will try to do that. So let's do RPMs are list. Instead of uploading, we will RPMs append path which is not that simple, because then we get lost information about the build ID and labels. So we can definitely create a something like this. This can be a dictionary, and we can or no, it can be a list, but we can append not path but structures like path equals path and labels equals labels. Then here we should have some pretty structure. So RPMs. Yeah, that's the reason why we didn't get the same NEVRAs when testing this, because these two are from the same build, and it's source RPM and RPM, but they are from the same build. So the NEVRA would change only for different builds. If we continue, where are we? And there is a yes. So now there is a different build ID and the same NEVRA, but that is a problem because upload build results is actually called for a build ID directory, like for this one, for example, and then for this one, so we cannot actually filter the results here. That sucks. That means that quite sucks. So I'm thinking we have two options. We can modify the API of this to take a list of RPMs and pre-filter it when passing it into this function, or that's the question, right? So on how many places this function is used, can we easily change it? I'm sorry. This is our upload script. These are our definitions. Here in storage 596. Oh, this is forking, okay. This is forking. And this is building. So we have, basically we have it on 3 places. So, okay, we could potentially add something like exclude NEVRA, and that would be, can we do it like this? Probably not a good idea. And exclude NEVRAs equals exclude NEVRAs or empty list. So I think we could have something like this. And then we could exclude them here, but that's also stupid. So okay, I think we have some function which is I have no fucking clue where, but it should basically find RPMs in a directory. And now that I say it out loud, I'm not sure if we have it in Copper or we have it in Fedora review or something like that. All the code bases are melting together in my head. Maybe let's try common helpers. So it's not here. There is some RPM. No. This is only walking in traversing directories. Okay. So probably not here. Damn. Git grep find grep RPM, something like that. Or maybe a list. A list grep RPM. What if we take a look at main RPM build? Okay. So if we build an RPM, then we build a run. Produce sources. No. What happens here? No. This is done on a result there. Okay, so I'm probably mixing up code bases in my head. This doesn't look like it has the code that I wanted to. Maybe Copper backend has it. No, Copper backend. Copper RPM build builds the results, and Copper backend then needs to find them and copy them to backend. But I don't think it does any filtering there or finding there. It just simply copies the result there as is. So the code is not there. Okay. This is getting a little bit complicated. We could ignore this whole function for uploading and write a new one, which is also a bit sucky, but the temporary migration script, maybe we can do it a bit. Maybe we can improvise a bit. It doesn't have to be so clean. And the benefit would be that we could only hotfix the script in production, and we could run it today, instead of like modifying 1,000 little files inside of the project and then having to do a full release or maybe a backend release. So what if we just create a new function here? We will then move it to the top, but whatever. And this function will be basically this, but we will hugely simplify it. So it will not be a method, it will not take max workers, it will not, I don't know, it will not be run as a thread. It will traverse the result there. Sure. This is something we don't have to have it here. Now, for future, okay, so the futures are happening here. I don't want any futures, and let's not do any appending either. Let's just take this. Put it here. Like this. So we have our try, accept, and these. Oh yes, these are file uploads. Where do we set the? Oh, this should have been set at the top. No, we can trace back right at the moment. So we can have an uploading function simplified like that. If file uploads, here we are appending, so instead we can instead we can raise the exception here, and instead of this we can raise the exception here. So we can heavily simplify the function. The file path is basically path, so we can rename it to path and delete this function variable. Future result, so response will actually be self-upload with these two parameters. What is equals name? This is what confuses me, but that doesn't really matter. Let's take this. So we will actually call this function with these two parameters, and it will not be self, but this needs to be a Pulp client. Do we have a Pulp client? Frontend client. Do we have a storage? We have a storage. I think we established that at this moment we have a storage, don't we? We need to have a storage. Storage is here. So what if we pass Pulp client to it? It shouldn't be none, because otherwise it would fail, but don't worry about it right now. So we would have a Pulp upload RPM with these two, and package hrefs append. Okay, package hrefs directory we should have probably. This is the... Okay, so this is basically outside of the loop here, right? Yes. So basically we can do something like this, and then package hrefs. So we don't have the logger here, and we don't have these two. Okay, never mind, ignore this. Good enough for now. Does Pulp function upload RPM with these two parameters exist? So pulp.py upload no. How is that possible? Upload RPM. So it's the storage class. That's not the Pulp class. See, it's here and it exists. So we actually need to we actually need to not take the pulp, but let's take the whole storage equals none, and it will be storage upload RPM. This is good. So we care about both package hrefs but also the paths of the files that we are uploading. So here maybe let's return tuple package hrefs. So it will be RPM paths and package hrefs. RPM paths will be an array so and no we will refactor actually, and we will create a new function, and it will be find build results where, so in a truth results dir and target dir name, that's the same. Thanks to this, we should be able to basically use something like this. Yes, all variables are defined, and we should be able to results equals and then results append path, and then finally return results. So this should give us all RPM files for a given build result directory. We can test this. So here where we do package hrefs, we will do RPMs equals find build results for the same truth result there and none apparently, as we do here, and we will have our debugger and execute the code. We are in the, yes, that's our new debugger. So RPMs, and we have these two. If we jump next, we are uploading, and then we are back inside of the migration script, RPMs, and this is the other build. Perfect. So with this, it seems we don't care about the target dir name. So let's just not do it. Now we can find the results. So what if I'm thinking, should we take the should we find results for a build, upload it, store the paths, and then go for a next build, but while doing so comparing the paths? Or should we just collect all the paths and then process it? And I'm thinking maybe we should just so if the scandir, and I have no clue if that's true, if the scandir goes by alphabetically, that would mean that our later builds are done later, and therefore we want only the latest one. So we can actually compare the build IDs, that we don't have to go alphabetically. So many freaking thoughts. So So at this point we know a build ID. How does that help us? So we can somehow parse the build ID from something, build ID from build there. It would be nice if we could parse the build ID from the whole path. So because then we could We want to go outside of the loop. We want to go here, completely outside of the loop. Uploaded, or maybe just RPMs, or RPMs, or uploaded path, uploaded RPMs. RPMs equals empty list. Then we could find build results. Let's say do something like, I know we didn't implement it yet, but we could do package hrefs also I don't know, paths equals upload build results, and let's say just RPMs like this. I know we don't implement it like this, but we could. It returns a tuple which is RPM paths and package hrefs, so it will be RPM paths and package hrefs. Then we could extend the package hrefs as we do, and we could upload at RPMs extend RPM paths. We could do this. And now at some point we create a repository version. So this should probably be defined at the same place that the all package hrefs is done. This is done on a weird place because okay. We don't have much time. We have maybe half an hour left. So we won't finish this probably. Oh, that sucks. I mean, we don't finish this on a video. I will definitely finish this today. We could do this. Now I confused myself because where do we here we add the results into the repository. So and when it's okay, we continue. I see now. Because it's for the truth. So these subproject entries, I'm not sure about those, but we definitely need to be outside of the truth loop with the uploaded RPMs, I mean. So it needs to go basically here. Basically here. And so at this point we are ready to call the create repo on package hrefs. So what if at this point we break and here we should basically filter duplicities in, and we cannot do it here. We cannot do it here because even if we find the duplicities of the uploaded files, we don't know their appropriate, relevant, linked, I don't know, their package href. So it's too late here. We basically need to skip the upload, actually. Do we need to skip the upload? So we know the RPMs, and can we just do basically for RPM in RPMs, if RPM in uploaded RPMs, right? Let's do if not, then continue. So if the RPM is inside, if the RPM with the same NEVRA, we cannot compare the whole paths. We need to compare only the base names. Don't compare full paths, but only base names. But let's keep this as a like a stub or draft. So if we have if the file was already uploaded, then we know a build ID of our current build. So we could do something like build ID. So if this build ID is smaller than the previous build ID, which would be previous build ID, then continue, right? But if this one is higher, then we basically need to pop. Basically, we need to pop the old RPM path from the RPMs list, and then we don't have to append, because appending is going to be done here. So that's good. So we only need to pop. Now there is so many to-dos. Find this using but from the whole path. There's so many to-dos that we need to figure out, but that's basically it. Give me a 2 minutes AFK, please. I'm back. So we have maybe 15 minutes, which means we will not finish this together, but we can pick one task out of this and try to finish it. So I think the most reasonable one would be figuring out the path, the build ID from the whole path instead of the build there. So if we put a breakpoint here and kill this, and again, so 181, we are at the right place. We know what's the correct one. Now we need to figure out the same, but from the whole path. What would be the whole path? What is the build there actually? Build there. So this is the build there. And if we jump a little lower, no, I need to. Let's put the. I don't know what was this one. Let's remove it for now. Let's put the breakpoint here, and let's have foo equals, or maybe let's say RPM equals RPM 0. Will this work? Yes, we have the RPM, and we know the build ID should be this. So how do we figure out from the whole path? So can we split? Can we write split from the slash RPM rsplit slash just once, twice actually. So we have the prefix, RPM name, and the build there. So if we return the, now we know the build there, and we can, okay, that looks good. So our function, I mean, this is definitely not like perfectly bulletproof solution, but in this case it should work. So if we do build ID from RPM path and do path, or maybe RPM path, RPM, let's do RPM. Now we can do this same shenanigans and we can have something like root path build dir file name equals this, and there is some magic like this from build dir return. So if we do this build ID, so okay, let's kill the process and again. So we know the original build ID was this. Can we, and we also have the RPM path. So can we build ID from path RPM, and it's the same one. Perfect. So this is our function, and we will start using. Do we start using this or do we not? Because at this point we don't have the, okay, no, we will not start using this probably, but we will definitely use it here. So we will use it here, but we don't have all the information that we need yet. So we cannot do it from the RPM. We need to do it from the previous RPM, right? This will be previous build ID. So we still need the previous RPM. And we cannot do uploaded RPMs. If it's inside, that's the problem. We cannot do just if it's in, we need to find it. And if it's in already uploaded paths. So so we cannot we need to compare this. So okay, let's keep the build ID on hold. We need to figure out the previous RPM, and to figure that out we cannot simply do this, and we cannot simply do find, because here we operate with full paths, and uploaded RPM are full paths, and they will never be the same because the build ID will be different there. So if we fake it, and we will do, instead of no, this is correct, we upload somewhere here. Okay, so if we fake it and say that upload that RPMs equals a list, and we put we had it somewhere. One path. Oh yes. So this is the first one, and this is the second one. So this is of course only for development purposes. So we have these uploaded RPMs. Now we should get actually here without any tracebacks. Main 200. Right, 200. And what do we know? Can we upload at RPMs and RPM? So this is the exact oh yes, because we okay. That's as expected. But the point we are trying to get to here is, can we do, for example, OS path base name for the RPM? We can. And can we do X for X in uploaded RPMs, OS path base name like this? So can we do in? Can we do something like this? If, then continue. We don't have to colon here. Now, if we run it again, upload. Oh, yes. And here we will do, can we do continue here? Successfully migrated. How is that possible? Try it again. So our previous condition was not in, right? That's it. That's the reason why. So that explains it. Now, if we do RPM, uploaded RPMs and RPM. So we already so 36. this one is already there. OS path base name not in continue. Oh yeah. Oh Jesus, my brain doesn't work. So that's also as expected, because if it's in, which it is, this one is in this array, then we want to do this magic and we trace back. So here, okay, so we cannot basically do this simple thing because we need to find out which one it is. So we need to go actually nested loop for uploaded, RPM in uploaded, RPMs, and then if this fun equals this fun again, but for uploaded RPMs, then we can break and we can return. We don't have to return. We know it's the uploaded RPM. So at this point, and we don't have to do this, by the way. Let's do it. Let's do it. We will definitely not need to do it later, but let's do it now. Uploaded RPM only. Now, 204, correct. Uploaded RPM is the whole path. So our previous RPM, good. And we can basically, okay. So at this point we get to here. So we have the RPMs, and we talked about popping the old RPM path from RPMs. By the way, RPMs is RPMs correct, or is I need to go, sorry. I need to go actually. I will definitely finish this today. So I think we are progressing, at this moment we are progressing quite fine. We actually wanted to pop this, so we will have the filtered out repository. We will implement, we will refactor this function to take the RPMs instead of finding them. And then we are golden, right? Hopefully it will work out that way. Anyway, see you next time.